Okay, guys, here we go. Looking at the stuff today, we're going to talk about using the discriminant. All right. And the important thing for you to know is the discriminant is the part of the quadratic formula that shows up underneath the radical. It's the b squared minus 4ac. And it's going to make perfect sense. You're going to think, well, yeah, of course. That makes perfect sense when we talk about it. But the value of the discriminant, when I plug in the numbers for b squared minus 4ac, it's going to give me a value. And that value tells me how many solutions this equation has. Okay? Now, I want to step away from that for just a moment, and I want to talk about quadratic equations. This is a quadratic equation. ax squared plus bx plus c equals 0. But we also have something called a related function. Y equals ax squared plus bx plus c. And I can graph that, and you guys know, because we've talked about this before, that I can graph a quadratic function, and it's going to give me a parabola. Now, a parabola sort of looks U-shaped, and you can see it in this one. I don't want to do that. Okay. All right. This one right here, this parabola, the vertex is below the x-axis, and when it turns up, it hits it twice. Okay? It hits it here, and it hits it here. And that's where the y is equal to 0. We'll go back up here to the related function. I replaced 0 with y. And when y equals 0, it gives me these x's. So these are the solutions to the equation. The x-intercepts are the solutions to the equation. Now, there are three terms that you need to know. We've certainly talked about solutions to the quadratic equation, but these are synonymous. Solutions, x-intercepts of the functions are the same thing as the solutions to the equation. And then another term that you need to know is the roots. The roots of the equation is where it crosses the x-axis. And that's the same thing as solutions. So if I say to you roots, I'm talking about solutions. If I say to you x-intercepts, I'm talking about solutions. All right? Now you can see there are three things that can happen with a parabola. It can hit the x-axis twice and have two solutions. Sometimes it's only going to hit it once. The vertex is actually on the x-axis. All right? And that one has one solution. Sometimes the vertex is above the x-axis or below if it turns down, and it doesn't touch the x at all. That one has no solutions. All right? So we can have 2, 1, or no solutions. I'm trying to figure out how that works. All right? Okay. And there are three ways. We don't need to graph it to know what those solutions are. All we have to do is look at these three things. b squared minus 4ac. Remember, this is the part that's under the radical. All right? So if it's positive, say like 5, then I'm going to have something plus that over something. That'll give me one number. And I'm going to have something minus that over a number. So that's going to give me two different values and two different solutions. If b squared minus 4ac is greater than 0, then there are two solutions. Okay? But now think about this. If the stuff underneath the square root sign is a 0, it doesn't matter if I add it or subtract it, I'm still going to get the same thing. So if b squared minus 4ac equals 0, that means I only have one solution. Right? And it's basically negative b over 2a. Wait a minute, what is negative b over 2a? That's right, it's the x-coordinate of the vertex. And in this one, that means the vertex is going to be right on the x-axis. It's the one solution to the equation. The last one here, if it's less than 0, say the square root of negative 5, that's not a real number. It is an imaginary number. We can work with it, but it's not in the real number system, so there are no solutions to it. All right? So we just need to memorize that. If it's positive, two solutions. If it equals 0, one solution. If it's less than 0, no solutions. All right? Great job, guys. James, quick, what you got?
Oh, what if it's like greater than or equal to?
Okay, this is just a rule for us. Okay? Hang on, let me stop this.